This video is part 2 from lesson 1, and lesson 1 we were dealing with angle measures in degrees. So this video should be much quicker because it mostly involves reference angles, which I already introduced to you in part 1. So reference angle, just to have a definition of it, it says that the reference angle is an acute angle formed between the terminal arm of the rotation angle and the x-axis. So for example, this rotation angle here is 120 degrees, you'd be told. So theta is equal to 120 degrees. So we call that a couple of things. It's either our rotation angle of 120 degrees, it is an angle in standard position, and it is also going to be a principal angle, okay? In order to calculate the reference angle, you always put a point on the terminal arm. That point you always connect with a vertical line to the x-axis, and the reference angle is going to be the acute angle that's formed from the origin, so within the triangle. So you say to yourself, okay, 120 degrees is right here. So you're going to use 120 degrees and you're going to use 180 degrees to get your reference angle. So theta r, which denotes my reference angle, is 180 degrees minus 120 degrees, and that would be a 60-degree reference angle. So that angle in there is 60 degrees. I often tell students to just sort of double check it, like make sure it makes sense in your mind. So from here to here is 120 degrees. If you add 120 plus 60, you get to 180 degrees, right? We know that a straight line is 180 degrees. Let's look at class example 4. In each case, state the rotation angle and state the reference angle. So 243 degrees. That's going to be in quadrant 3. The angle in standard position, we know will terminate in quadrant 3, right there. So that's 243 degrees. That is what my angle in standard position is, okay, or my rotation angle. Rotation angle, angle in standard position can be used interchangeably. So that is 243 degrees. The reference angle is always found in the triangle. So a point on your terminal arm, vertical line to your x-axis, and it will always make a triangle, and it will be this angle here, that's the reference angle. The numbers you use to calculate that will be this 180 degree and 243 degrees. So theta r is equal to 243 degrees minus 180 degrees. My reference angle is going to be 63 degrees. How could you check that? How could you check that this is 63 degrees? Well, halfway around a circle is 180 degrees. If I add 63, so 180 plus 63, I will get a final answer of 243. B, 337 degrees. We know that this is 270 degrees, so we're going to be in the fourth quadrant. So I've got my initial arm, and it's going to open up, and it's going to terminate in quadrant 4. So this would be 337 degrees. That is theta, right? So that is my angle in standard position. That's my rotation angle. In order to get my reference angle, you draw a point on your terminal arm, vertical line to your x-axis, and your reference angle will be that angle in there, which is calculated using 337 degrees and 360 degrees. So 360 degrees minus 337 degrees, theta r is going to be 23 degrees. Last question is 70 degrees. So 70 degrees I know is going to terminate in quadrant 1. So that's 70 degrees. That is my angle in standard position. And if I said, well, what's my reference angle? Quadrant 1, draw your point on your terminal arm, go down to your x-axis, and what is that little angle there? It is also 70 degrees. So my reference angle is equal to the angle in standard position. Quadrant 1, if you want to make note, it's the one quadrant where your rotational angle, your principal angle, will be the exact same as your reference angle. So if I gave you like an angle of 35 degrees and I said, what's the reference angle? It would be 35 degrees. Okay. The only thing that I want you to make note of here and highlight here, and we'll see this on one of the examples, if the rotation angle is not between 0 and 360, what we need to do is we need to convert it back to that principal angle in order for the relationship to be valid. So we'll see that with class example 5C, that if we're outside of 0 and 360 degrees, we need to figure out what the principal angle would be, and then we could calculate the reference angle. Okay, let's go to class example 5. State the reference angle for each of the following rotation angles in standard position. So let's do this. All right, 195 degrees. So remember, you're always going to be given a Cartesian plane that's not labeled, or you'll be drawing your own. So we know that this is 180 degrees. 195 would go slightly past that. 195 degrees. If I was to draw my angle in standard position, or my rotational angle they call it, theta is equal to 195 degrees. They are interested in the reference angle. So the reference angle is made from the acute triangle, and this little angle here would be the reference angle. That angle is calculated by using 195 degrees and 180 degrees, and you would subtract those two numbers. 195 minus 180 gives us a reference angle of 15 degrees. Make sure that that makes sense. So 180 plus 15 plus this little 15-degree angle gives me 195. Okay, negative 258. So this goes back to what we had highlighted over here. The rotation angle must be between 0 and 360. If it's not, we need to convert it to the principal angle. So what you do, if you have a negative angle, you're going to simply add 360 degrees. The principal angle, its coterminal to negative 258, is going to be 102 degrees. Okay, so negative 258 and 102, those are coterminal with each other. They terminate on the exact same spot. We could easily see where 102 degrees is, right? This is 90 degrees, this is 180, so 102 degrees would be here. So we always draw our principal angle, and when we're finding our reference angles. So this angle here is my principal angle. It is 120 degrees. I'm going to put the 120 there. To find the reference angle, always draw a point on your terminal arm and make your triangle. It's this angle here, that little acute angle there, that purple angle. So in order to find that purple angle, which is theta r, what we do is we take 180 and we subtract 120. And that answer is, sorry, not 120, 102. Let me fix that. This should be 102, and this should be 102. 180 degrees minus 102 degrees gives you a reference angle of, what would that be, 78 degrees. Okay, negative 810. We are not in that domain of 0 to 360 degrees. So what we have to do is we have to find out what's coterminal with negative 810. So you're essentially just going to keep adding 360 degrees. So we have negative 810 degrees, and coterminal with that is going to be negative 450. We're going to add another 360, so coterminal will be negative 90. And then I'm going to once again add 360 degrees to give me 270 degrees. So negative 810, it is coterminal, that angle terminates at the same position as negative 450, negative 90, and 270. But this would be the principal angle. So that's the angle that we're going to write and we're going to deal with. So 270 degrees. This 270 degrees, we know that that's 180. This is 270, and this would be 360. So 270 degrees is essentially my angle opening, and it is going to terminate on the y-axis. And the reference angle, so the reference angle is, well, how many degrees do you go from 270 to 360? That's a 90-degree reference angle. So theta r is 90 degrees. Last question. Determine the four angles between 0 and 360 which have the same reference angle as a rotation angle of negative 128. Okay, first thing I need to do, I need to find out what the principal angle is. So I'm going to take negative 128 and I'm going to add 360 degrees. That gives me a principal angle of 232 degrees. So 232 degrees, these two are coterminal with each other. So I'm going to just deal with this 232. 232 would be 180, 270. It would be in quadrant 3. So 232 degrees would be in quadrant 3. That reference angle is going to be this angle right here. And in order to calculate that angle, it's 232 degrees minus 180 degrees, and that gives me a 52 degrees reference angle. Now what they're saying is determine four angles that have this same reference angle. So how you would do that, in quadrant 3, my answer would be 232 degrees, right? Would have a reference angle of 52 degrees. If I draw another Cartesian plane and I put 52 degrees here in quadrant 1, and I say, well, what's this reference angle? The answer is 52 degrees, right? So the theta r in quadrant 1 would also be 52 degrees. So this angle has a reference angle of 52 degrees. 232 has a reference angle of 52 degrees. Let's put 52 degrees in quadrant 2. So if I put a 52 degree reference angle here, and I say, okay, what's the angle in standard position? So what would that angle be? 180 degrees minus 52 degrees would give us 128 degrees. So this angle, 128 degrees, has a reference angle of 52 degrees. The only other quadrant I need to deal with now is quadrant 4. So quadrant 4, draw a reference angle of 52 degrees. Remember, your triangle always goes up to the x-axis. So if I said, okay, yes, that's a reference angle of 52 degrees, well, what's the angle in standard position? So the angle in standard position is always from 0 to where that terminal arm terminates. And I want to figure out what that is. So what I would say is, okay, well, one complete rotation is 360 degrees. If I subtract this 52 degrees, I would get 360 minus 52 is 308 degrees. So this angle would be 308 degrees, and 308, so let me just fix that, 308 would have a reference angle of 52 degrees. So the question is saying, what are four angles that have a reference angle of 52 degrees? And those four angles are, in quadrant 1, it'd be 52 degrees. In quadrant 2, it would be 128 degrees. In quadrant 3, it would be 232 degrees. And in quadrant 4, it would be 308 degrees. All four of those angles in standard position have reference angles of 52 degrees.